In the roughing video, I went through programming 2D and 3D adaptive clearing, but there were a lot of parameters I skipped over. So I'll take a more in-depth look at some of the settings in adaptive clearing, and a lot of what I'll cover will be true across multiple operations in Fusion 360. I'll use this existing 3D adaptive operation. In the Tool tab, I can of course select a tool, edit the coolant type, and I can edit the feeds and speeds for this individual operation. None of the changes I make here will propagate back to the tool library, they're only for this particular operation. So this is a good way to make edits for roughing or finishing passes without affecting the tool library settings. Under Geometry, I can set a machining boundary using one of three options. A bounding box makes a rectangle that contains the entire model, a silhouette is a projection of the outer contour of the part, or a selection that I can pick directly off the geometry. I'm going to switch gears briefly into contour selection, which is key throughout the CAM workspace. When I'm picking my contour, Fusion tries to guess what I want, but in this selection, the machining boundary isn't including the saw, which is what I actually want to rough out, so I need to edit this contour a little. I'll click on it again and I enter Contour Editing Mode, which contains 5 commands. The first 2 are to open or close the contour, which isn't currently an option because machining boundaries need to be closed. Then I have Accept, which will save the contour with any changes that I make, Cancel, which will keep the contour selected but not save any changes, and Delete, which will unselect the entire contour. The portions of the contour are also colored blue and black, where blue indicates a portion that I have selected, and black indicates where Fusion tried to fill in the blanks. I can edit the contour by adding or removing selections, and Fusion will update its automatic selections. I'll click Accept, and now I've saved the edited contour. Back to the Geometry tab, the next thing is Stock Contours, which lets Fusion know where the stock begins and trims or lengthens the toolpath appropriately so that there's less time spent cutting air where there's no stock. I can make a contour selection just like in the machining boundary, or if I have nothing selected, it uses the silhouette of the stock defined in the setup, which is the yellow rectangle I see now. Rest machining enables Fusion to calculate a toolpath that takes into account what stock has already been removed by looking at the setup stock or the result of previous operations, which also helps reduce time cutting air. Tool orientation is available in Fusion Ultimate and allows me to do positional 4 or 5-axis machining by defining a different work coordinate system for this operation. Model allows me to override or add to the model I defined in the setup. I can select surfaces or bodies to be included in the model for toolpath calculation, and if I uncheck Include Setup Model, then my selections will be the only objects used in toolpath calculation. Next for heights, each height is defined based on a reference, which can be one of the other heights, the model top or bottom, the stock top or bottom, or a selection which I can choose directly off of any geometry in the workspace. Then I can define an offset value from that reference. I can also set heights a little more quick and dirty by grabbing the plane and dragging it to wherever looks good. In the Passes tab, there is a lot going on, and this is a good time to remind myself that if I ever forget what something is, I can hover over the parameter and see a tooltip that explains it. Starting from the top, the tolerance is going to set how tightly the toolpath fits the model geometry. Enabling shallow areas adds finer step-downs on shallow parts of the model to machine them more accurately. Optimal load sets the optimal engagement for the tool, similar to the step-over in a legacy clearing toolpath, but instead of basic offset passes, this enables the algorithm to keep the same load on the tool throughout the toolpath without over or underloading the tool. The minimum cutting radius is the parameter that keeps the tool from getting put into a corner where a high portion of the tool would be engaged. I can decrease this to allow the tool into smaller areas. Machine cavities allows the tool to go into closed pockets. If this is disabled, the toolpath will only machine areas that can be reached from the outside of the part. Slot clearing clears out the center of the slot and then does offset passes rather than the typical adaptive tricoidal style passes. The maximum roughing step-down defines the biggest step adaptive clearing will take, and the fine step-down defines the small step-up passes that come after the first large step-down. Flat area detection finds flat areas on the part and tweaks the step-down parameters slightly to cut right at those depths. Stock to leave will leave some material behind in the specified direction, so there is something to remove in semi-finishing and finishing passes. I can also enter a negative value here to have the toolpath remove slightly more material than what's defined by the model. Stock to leave appears in nearly every operation, so it's easy to make features over or under size if needed. Smoothing will fit lines and arcs to the generated curves and can significantly reduce the amount of code that feeds into the controller. Moving on to the linking tab, I'll go deeper into the stay-down parameters. The first parameter, maximum stay-down distance, is the longest path length that any stay-down move will make. The larger the amount entered here, the longer the stay-down moves are allowed to be. Stay-down clearance is the smallest radial distance allowed from the tool to any obstacles. The stay-down level I like to think of as a calculation timeout. The higher the stay-down level, the longer the calculation time Fusion will allow, resulting in more stay-down moves. Lift height will lift the tool off the material while executing the stay-down move. Finally, no engagement feed rate is where the stay-down moves can really save time if I enter a high feed. I usually go for at least my cutting feed rate, if not something closer to the rapid feed of my machine, so that the reduced distance saves me time. Those are all of the adaptive clearing specific parameters that really need additional explanation. These parameters largely carry over to 2D adaptive clearing as well, but there are some key differences that I'll go through in this existing 2D adaptive. First is that I need to select the geometry I want to clear out. I can do so by selecting faces or contours of pockets, but I recommend selecting contours as this gives extra control with the contour editor. The second difference is under the Passes tab. There are no automatic step-downs. I can enable multiple depths to set a step-down length, but there's no fine step-down because 2D Adaptive doesn't recognize surfaces to apply them. That was an in-depth look at 2D and 3D adaptive clearing.